massive earthquake triggers an avalanche, destroying history in seconds and triggering a desperate search for survivors.
Langtang village was one of the most popular trekking destinations in Nepal and home to 435 people. But there is virtually nothing left. The earthquake caused a massive avalanche and a landslide. It's hard to believe, but 55 hotels and guest houses and the villagers' homes are gone under this great tongue of ice and rock.
A devastating 7.8 magnitude earthquake struck northern Nepal on April 25 of 2015, injuring over 22,000 people and killing over 8,000, in addition to causing significant infrastructure damage. The quake caused an avalanche on Mount Everest that killed at least 18 climbers, injured 41 others, and trapped hundreds, making it the deadliest day on the mountain to date. Hundreds of impacted people required safeguarding and evacuation. In addition, intermittent electricity, cell tower, and landline outages meant several people were stranded. Surface phenomena earthquakes often cause dramatic geomorphological changes, including ground movements, either vertical or horizontal, along geologic fault traces, rising, dropping, and tilting of the ground surface, changes in the flow of groundwater, liquefaction of sandy ground, landslides, and mud flows. The investigations of topographic changes is aided by the geodetic measurements, which are made systematically in several countries seriously affected by earthquakes.
Earthquakes can do significant damage to buildings, bridges, pipelines, railways, embankments, and other structures. The type and extent of damage inflicted are related to the strength of the ground motions and to the behavior of the foundation soils. In the most intensely damaged region, called the mesoseismal area, the effects of a severe earthquake are usually complicated and depend on the topography and the nature of the surface materials. They are often more severe on soft alluvium and unconsolidated sediments than on hard rock. At distances of more than 100 kilometers from the source, the main damage is caused by seismic waves traveling along the surface. In mines, there is frequently little damage below depths of a few hundred meters, even though the ground surface immediately above is considerably affected. Earthquakes are frequently associated with reports of distinctive sounds and lights. The sounds are generally low-pitched and have been likened to the noise of an underground train passing through a station. The occurrence of such sounds is consistent with the passage of high-frequency seismic waves through the ground. Occasionally, luminous flashes, streamers, and bright balls have been reported in the night sky during earthquakes. These lights have been attributed to electric induction in the air along the earthquake source.
An earthquake is a perceptible vibration of the surface of the Earth. The crust of the Earth, the lithosphere, is a patchwork of continental plates that slowly and constantly move in diverse directions, shoving against one another. When the tensions in the plates deriving from the movement and shoving exceed the strength of the crust, an earthquake occurs. These tectonic earthquakes are the most frequent and strongest, but they can also derive from volcanic eruptions or mining activities. Volcanism describes geological activities that relate to the rising of the magma from the mantle of the Earth up to the surface. Volcanoes can evolve at the collision lines of the continental plates, oceanic trenches, on mid-ocean ridges, and at so-called hotspots. Hotspots are irregular formations in the crust underneath the continental plates. Volcanic eruption material can be solid, liquid, or gaseous. The most popular form of volcano is shield volcanoes that erupt extremely hot, pure liquid lava. As it flows with great speed of 60 km per hour, It leaves a large area covered with a huge flat shield. Stratovolcanoes erupt all kinds of volcanic material. The magma of stratovolcanoes derives from upper layers of the mantle, from the bottom of the crust, and from an upper layer of the interior, and contains more gas. Therefore, different kinds of volcanic material erupt in the faces of explosions of solid materials, ashes, lava, and gases. Earthquakes and volcanic eruptions can also trigger other disasters, such as tsunamis, volcanic winters, glacial lake outburst floods, or lahars. Tremendous volcanic eruptions can burst huge amounts of ashes into the atmosphere, which can shield the Earth from the radiation of the Sun and consequently diminish the Earth's temperature or the average temperature of the Earth for some amount of time.
Among the most dramatic and visible creations of plate tectonic forces are the lofty Himalayas, which stretch 2,800 kilometers along the border between India and Tibet. This immense mountain range began to form between 40 and 50 million years ago, when two large land masses, India and Eurasia, driven by plate movement, collided. Because both these continental land masses have about the same rock density, one plate could not be subducted under the other. The pressure of the impinging plates could only be relieved by thrusting skyward, contorting the collision zone, and forming the jagged Himalayan peaks. About 225 million years ago, India was a large island still situated off the Australian coast. And a vast ocean called the Sea separated India from the Asian continent. When Pangaea broke apart about 200 million years ago, India began to forge northward. By studying the history and ultimately the closing of the Tethys, scientists have reconstructed India's northward journey. About 80 million years ago, India was located roughly 6,400 kilometers south of the Asian continent, moving northward at a rate of about 9 meters per century. When India ramped into Asia about 40 to 50 million years ago, its northward advance slowed by about half. The collision and associated decrease in the rate of plate movement are interpreted to mark the beginning of the rapid uplift of the Himalayas. The Himalayas and the Tibetan Plateau to the north have risen very rapidly. In just 50 million years, peaks such as Mount Everest have risen to heights of more than 9 kilometers. The impinging of the two land masses has yet to end. The Himalayas continue to rise more than 1 centimeter a year. That is equivalent to a growth rate of 10 kilometers in a million years. If that is so, why aren't the Himalayas even higher? Scientists believe that the Eurasian plate may now be stretching out rather than thrusting up, and such stretching would result in some subsidence due to gravity.
The World Aware team provided up-to-the-minute situational intelligence to client organizations and conducted several operations to locate, validate proof of life, safeguard and evacuate impacted people countrywide in Nepal. World Aware's team monitored the unfolding situation in Kathmandu and the surrounding region to ensure all affected people were sheltered in place during multiple strong aftershocks that brought on mudslides and further infrastructure damage, making some roads impassable. When the 7.8 magnitude earthquake hit near Kathmandu, Nepal on April 25, 2015, World Aware's Global Integrated Operations Center team issued an alert to all clients. World Aware raised its global readiness level to alert and began triaging calls for assistance from organizations with impacted people in Nepal. An incident management team was assigned and immediately began coordinating with local resources to assess the situation on the ground in Nepal, conduct route surveys, identify locations for safe havens, and planning to recover and assist people countrywide with evacuation or emergency relocation.